Well, welcome back to my kitchen. Time for a little bit more science in Mr. Matt's kitchen. Um, Last time we spoke, I spoke, we talked about the ways that heat can be conducted. Remember those three ways are conduction, which is through direct contact, convection, when the heat is carried on some other material, like you heat up some air and then blow it somewhere, like with your blow dryer or whatever, and then radiation, which is when heat is transferred through waves or rays, like how the sun heats up the earth. Uh, Now, that heating is responsible for all of the weather that we have on this planet. So, we're going to continue talking a little bit more towards getting into actual weather. First, we need to talk about a thing called the hydrosphere. We've been talking about the atmosphere. The atmosphere is the thin layer of gas that surrounds the planet. Well, the hydrosphere is just all of the water on the Earth's surface. So lakes, rivers, oceans, any puddles you have in your backyard, the water on that's been absorbed into the ground, that's the hydrosphere. Now, due to heating, a lot of the water that is on the Earth's surface will evaporate and enter into the atmosphere. And then as it cools, it condenses and falls back down onto the planet, back onto the hydrosphere, in a cycle that's constantly going on. And that cycle is called the water cycle. There are several parts to it. As I said, as the sun heats the surface of the earth, some of the water evaporates. It goes up into the atmosphere in the form of a gas. As it rises, it cools. It will eventually cool to the point where it will condense and turn back into a liquid. In small amounts, that condensed water becomes a cloud. As the water droplets get bigger or form on other particles in the atmosphere, they get heavier and start to fall as precipitation, rain, snow, sleet, hail, whatever. It falls back to the earth, where the cycle just starts over again. So it's just cycling between evaporation, condensation, precipitation, evaporation, condensation, precipitation. Now, the rate at which that happens largely determines the weather that we have, and that also, coupled with the atmosphere, determines the livability of a planet. Mars, for instance, Mars basically has no atmosphere. Because it has no atmosphere, it doesn't have a way to hold on to heat, so it has really wide ranges of temperatures. If you ever spend a day on Mars, which some of you may very well do that at some point, daytime temperatures run around 35 degrees Celsius, and the nighttime temperatures, because there's no atmosphere to hold in the heat, go down to about negative 170 degrees Celsius. Now, I know you think, well, those are cool numbers. What do they mean? Because we don't do Celsius. 35 degrees Celsius is roughly 95 degrees Fahrenheit. So a normal August day in Georgia. Not horrible, right? This, however, your nighttime temperatures, not quite as comfortable. So Mars is not a great vacation spot just because the nights aren't going to be the most palatable. So that's basically no atmosphere. Moon has a similar problem. It doesn't get quite as hot because it's farther away from the sun than Mars is, but it still experiences those really wide range things. Now, Venus, on the other hand, Venus has a very dense atmosphere. It's really thick, and because of that, it holds on to a lot of heat. It doesn't let heat go, and it pretty much stays around 470 degrees Celsius, which again, that sounds hot just as it is, but in Fahrenheit, that's almost 880 degrees. You would cook quickly on the on the surface of Venus. So if you have vacation plans to go to Venus, I would work on changing them. Sorry, there's a garbage truck outside. Have to deal with trains at the conference center. Garbage trucks here. No big deal. Alright, now, that brings us to wind. We all know what wind is. But have you ever thought about what causes wind? So wind comes from a few different factors. Some things you probably didn't think about. So the Earth's surface. We know, you've heard the statistics that, 3/4 of the Earth's surface is covered by water. The rest is land of some form, land or ice. And those surfaces react differently to heat. Water heats up more slowly, but also holds on to heat longer. And because of that, the Earth heats unevenly and cools unevenly. The ground cools faster than the water does, and that affects the air above it. And we all know hot air rises, cold air sinks. So that's one factor. Another factor is the fact that the sun doesn't shine evenly on the entire planet. You have the Earth, the sun that's shining here on the equator, the rays are hitting it directly, whereas these up here are hitting it at more of an angle. If you think about it, if you shine a flashlight, you shine it straight down, you get a really bright spot. I don't know why you can't see my hand down here. You get a really bright spot right there, but if you shine it at an angle, it spreads out and isn't quite as bright. The same thing happens with the sun. You get direct sunlight here, you're getting full energy over a small area here. The same amount of energy is being spread out over a bigger area, so it's hotter here than here, which means this air heats more than this air. And we know that hot air rises, so this air tends to rise up like this. And as it does, this colder air comes in to replace it, and it pushes the air this way, which starts to cool and it starts to sink, and you get this cycle. Now you would think that it would cycle all the way up here and come down. It actually doesn't. The Earth actually has this heats and sinks here, and then we're the same thing up here, and then other side it goes the other way. So you get these three bands of winds. But if you look at this, well, sorry, just look at the video, it looks strange. If you look at this, it looks like the winds should go north-south, but they mostly don't. I don't know if you pay attention to weather much, but you'll notice that the winds actually tend to go more east-west. My question is, why? Alright, so the answer is a word that you probably haven't heard. You may have. It's a thing called the Coriolis effect. Coriolis effect. Alright, so imagine you're sitting on a merry-go-round. You're on one side, your friend's directly across from you on the other side, and you have a ball. You throw the ball back and forth. Sitting still, no problem. You throw the ball, it goes straight to them. They throw it back, comes straight back to you. But you start spinning the merry-go-round. As the merry-go-round's spinning, if you throw the ball straight to them, where's the ball going to go? So if you're on the merry-go-round, you're going this way, you're going this way. When you throw this ball, even though you're throwing it here, it's going to look to this person like it curved that way. But really what happened, the ball went straight. Someone looking down on top of it would see that the ball went straight and this person moved. But to these people, it's going to look like the ball curved away from the rotation. I did that in my notes too. Well, the same thing happens with wind on the Earth. Because you're on a globe, Alright, so the cold air is headed down this way, but the Earth is spinning this way, so it tends to curve that way, and then the south it curves this way. Again, the air is actually going straight, it's the Earth moving underneath it. But it is an apparent effect, and because of that reason, hurricanes in the northern hemisphere spin one direction, hurricanes in the southern hemisphere spin the other direction. Now, there is a section in your book about different bands of winds and how that allows navigation and things like that. Feel free to look over them on your own. Your assignment, I think I'm changing this a little bit from what Mrs. Bowling sent out. It's in your favor, getting rid of one of the questions. So on page 443, do questions 2 through 5, and that's it for today.